So we're going to look at some information that I forgot to discuss during class, and that is how we can use UV-Vis spectroscopy to actually get a pKa value. So we're not going to have time to go over this during class, so this is why I made this video. So what we need to do is first we need to recall a few things, especially from maybe some stuff from Gen Chem. And so what we need to recall, so I'll just say remember. So we need to remember first that when we are talking about an acid, and I'll just use a generic acid, so HA, and if we're going to put this in water, we're going to have this dissociate into now H3O plus now Ra minus, right? So we have these guys, and this is the dissolution of an acid in water. And so if I want to come up with the Ka value for this, right, then what I need to do is I'm going to have essentially, I'm going to remove some water, but I'm going to say that Ka is equal to a minus, concentration of A minus divided by the concentration of HA. And then if we want to get a pKa value, right, so pKa is just the negative log of our Ka value. Now, another important aspect that we need to remember from this is the Henderson-Hasselbalch equation. And so what this is basically is an equation that allows us to relate pH to pKa. So this equation says that pH is equal to pKa, and then here's the key, plus the log of the concentration of A minus divided by HA. So, and essentially the log now of Ka. Well, what we need is we need pH to equal pKa. We can get that when the concentration of A minus is equal to the concentration of HA, right, because the log of 1 is equal to 0. Right, so what we need then is we need to get to a spot where we can have these two situations be true. So we need the 2 A minus to equal HA. Okay? With that in mind, we can kind of come back now and we can think about the let's say a titration curve, and what a titration curve looks like. So you have to remember from Gen Chem a titration curve. And so what this is basically, right, we're going to have some curve that looks like this, and on one side we're going to have pH versus the other side we're going to measure it against some volume. And typically what you can see is that you begin to get something that looks like this, right? Where we have something right here, which we might say is the equivalence point. And this is where all of your acid, if you're titrating an acid, so this is where all acid is converted to the conjugate base. Now, in between this point and the beginning is a spot right about here, and it is this spot where pH is equal to pKa, because at this point A minus is equal to HA, concentrations of course, right? So this is the point where pH is equal to pKa. So here's the important aspect of this. Notice that this is 1/2 way between the equivalence point and the start, right? So the idea is here, because of this, that if you have a situation where one species, so if only one species absorbs light, so either acid or the conjugate base, then essentially, and let's say this way, if we're doing with the only, not the acid, but let's just say now if we're going to take just the conjugate base, and we're going to, essentially what we're going to do is take a graph of absorbance versus pH. So if we do a graph of absorbance versus pH, what we will see is that we'll end up with a very similar curve as our titration curve, right? Something like this. However, what you should notice, because we're looking at the point where absorbance of conjugate base, right? The absorbance of conjugate base should equal, should be about half of what its max. The reason it should be half is because that's the point where the conjugate base, A minus, would equal the amount of acid that's in solution. So right here. And because of what we described above, this is the point where pH is equal to pKa. So that's how you can go about solving these types of problems, is noticing the fact that you have these different points on your different graphs. So that's why, for instance, it is half of the amount. Right? So hopefully this will help you with problems 14.42 and 14.126. Okay? And as always, if you have questions, come and see me.